Today, I'll be talking about how waves and iPhone cameras interact with each other. Now, cameras are known for capturing and storing images and videos and have evolved throughout history, but with the rise of smartphones, they're now the common use of photography. When the first iPhone came out, it had no LED flash or front camera. Now, many iPhones today have larger lenses and can take higher resolution photos. The iPhone camera in general has many parts to it. It has a wide-angle camera to reach a larger field of view and a 3D camera for depth perception. They also have a front camera used for selfies and video calls and a rear camera that is used for capturing photos in a different point of view, which I'll explain in more detail soon. The main point is that iPhone cameras use different forms of waves across the electromagnetic spectrum, specifically visible light waves and infrared waves. Visible light waves are a form of electromagnetic radiation that is mostly visible to the human eye and are between infrared and ultraviolet waves. In regards to visible light waves, iPhones consist of a lens system that's able to focus on the amount of light that's being transmitted through the camera. Meanwhile, the aperture is able to control the amount of light coming through, which is shown when I adjust my portrait in order to control the light that's in the background. Going back to lenses, iPhone cameras use convex and concave lenses. But what are these lenses? Convex lenses are lenses that focus on incoming light. When zooming and focusing in on something, the light rays and focal lengths are focused onto the image sensor. Concave lenses are lenses that cause light rays to spread apart, meaning that they cover a lot of details in a photo. iPhone cameras also use an image sensor known as a CCD. Well, a CCD stands for a charge-coupled device, and in a camera, each pixel consists of an area potential well in which incoming photons are later converted into electrons. Also, visible light waves are present in night photography. Despite it being dark right now, my camera is able to adjust and interpret incoming light waves, later collecting them. Infrared waves also relate with iPhone cameras and are also a form of electromagnetic radiation that are longer in wavelength compared to visible light but short in frequency. In fact, we humans cannot see these waves, but we encounter them every day in life. This can be shown with Face ID, which is a system in Apple products that allows an individual to unlock a device with their face and is enabled by a trued-up camera. Here's how parts in the trued-up camera are able to work in order. Here's an example of me doing the same thing, except I can't see the infrared dots.